Hello everybody, my name is Benson Chu and I am a compiler engineer at Texas Instruments. In my lightning talk today, I will talk about how I enabled the MachineOutliner LLVM pass for the Thumb-1 ISA. So earlier this year, we noticed that a guy named Yvonne had enabled a pass called the MachineOutliner for most of the ARM architecture. And looking through the code, we had noticed that he had explicitly disabled this pass for architectures that were Thumb-1 only. So we saw pretty good code size improvements of about 2 to 3% in most of our targets, but our Cortex M0 chips, which only have access to Thumb-1, did not see any benefit. So I had to look into how easy it would be to get the outliner enabled for Thumb-1. So what is the MachineOutliner? Basically, you can think of it like a reverse function inliner. The MachineOutliner will hunt around for sequences of instructions that repeat multiple times. So, for instance, in this example, we have this sequence that appears 3 times, and the MachineOutliner will try and pull that sequence out into its own function and replace each of these sequences with a call to that new function, as long as it reduces code size, which in this case it does. Here's a more specific example of what the outliner might do. Given this function f and the repeated sequence bcd, the outliner will pull this sequence aside and create a function, insert a return instruction, and then a call instruction to this new function, as well as save and restore the link register. So that's what the outliner does. Now I want to talk about what it takes to enable the outliner for a new target. I'm simplifying a bit, but basically it's a 3-step process. Step 1 is marking the instructions that are unoutlinable. Basically, what this will do is inform the outliner where it can't outline across so that it knows where to hunt for repeated sequences. Once those sequences have been found, they will be passed back to the target, at which point the target will get to decide whether or not to outline or to not outline. And if the for the sequences that are going to be outlined, a strategy needs to be chosen. After that, the target also needs to figure out what instructions to use for each of the strategies for doing the calls and then building the frame. So this work has been mostly done by Yvonne, and I needed to do some target-specific overrides for the second item, but the third item was completely on me, and where the majority of my work was spent doing. Particularly, there was one strategy where I had a very hard time figuring out what sequence of instructions to use, and that's one that required saving and restoring the LR, because the pop instruction, while it's pretty easy to get the LR on the stack, getting it off with the pop instruction is actually quite tricky, because the LR is not a valid register that can be passed to the pop instruction. So eventually, after much experimentation, I was able to come up with this sequence, which mostly does the job. Here's where the actual save and restore occurs. Once the LR ends up on top of the stack, in order to get it off, we must first pop it into a low register being R0 through R7, and then we can spend an extra instruction to move it into position. Now, this relies on a low register being free, so instead of hoping that a low register is free, we could just push an additional register onto the stack to ensure that we have enough room to get the LR back off of the stack and into the LR. And then after that, we can restore the value of whatever register. And one other thing of note is that this second register must not be modified by the outline sequence, because if it were, then the live out value of R4 changes, and then which affects the behavior of the rest of the function, which is just not ideal. So yeah, that's the solution. In Thumb-1, when the MachineOutliner needs to save and restore the LR, we must first check if there is a low register that is not being modified. As long as this is the case, we can use this template to do the outline. And that was basically the majority of the work. The rest of the instructions required to insert calls and build frames are basically just one-to-one mappings, like the return is just a BXLR, call is just a branch link, etc., simple stuff. And there were a few target-specific overrides that I needed to make to outlining candidate info to implement the logic that I mentioned earlier regarding there needing to be a low register when we need to that's unmodified when we need to save the LR. And that's basically it. This change set is still in review, so you still have time to stop by and make fun of my code before it lands on main. Also, the second link is a link to an article written by Yvonne, where he documents the work he did to enable the outliner for the rest of ARM. I hope both my work and Yvonne's work will encourage you to enable the outliner for your target of choice. Hope you learned something.